Now we have at least two temperature scale, that is the Celsius scale and the Kelvin scale. Okay. The relation between the temperature in Celsius scale and the Kelvin scale is, as we have discussed, T in Kelvin scale, T in Celsius scale is equal to the T in Kelvin scale plus minus 273.16. So it means that if you know the temperature in Kelvin scale, and you can transform it into the Celsius scale using this relation. But what we also have between the Celsius scale and Kelvin scale is that the change of temperature in Celsius scale is equal to the change of the temperature in Kelvin scale. That is, we use the same scale for the Celsius scale and the Kelvin scale, but we use a different reference point from these two scales. So if you know the change in the change of the temperature in Celsius scale is equal to the change of the temperature in Kelvin scale. The Celsius scale and the Kelvin scale is not only the temperature scale we have many temperature scale exist in the past, and some of them still is still used now. One of the most familiar temperature scale and used in the United States is the Fahrenheit scale. This temperature scale, the Fahrenheit scale, is defined at the freezing point of water. It's defined at the freezing point. Freezing point is defined as the temperature of the 32 degrees Fahrenheit and the boiling point is defined as 212 degrees Fahrenheit. Okay. So you can see that the scale of the Fahrenheit scale and the Celsius scale are different. The Celsius scale, we define the freezing point at 0 degrees Celsius, and the boiling point is at 100 degrees Celsius. So the temperature difference between the boiling point and the freezing point is 100 degrees. But for the Fahrenheit, the temperature difference between the boiling point and the freezing point is 180 degrees. So the scale of these two temperature scales are different. We can transform the temperature between the Celsius scale and the Fahrenheit scale using this relation, that is temperature in Fahrenheit scale is equal to the 9/5 times the temperature in Celsius scale plus 32 degrees Fahrenheit. From this expression, you can see that this term 32 Fahrenheit is the shift of the reference temperature at freezing point of water, because at freezing point of water the temperature in Celsius scale is equal to 0, and if you put 0 here you get the 32 degree Fahrenheit here. And this 9/5 is the change of the scale of the temperature, because as we have discussed, the scale of the temperature in between the Celsius scale and the Fahrenheit scale are different. So it means that the change of the temperature in Fahrenheit scale is not equal to the change of the temperature in the Celsius scale, but is equal to the 9/5 of the change in the Celsius scale. So we have to be careful when we use the different temperature scale, especially when we talk about the change of the temperature, because the scale of each temperature scale are different like this. If you compare the change of the temperature between the Celsius scale and the Kelvin scale, that's fine because they are equal. But if you compare the change of the temperature in Fahrenheit scale and the Celsius scale, you have to be careful because they are not equal. And furthermore, they also not use the same reference value of the they use the different value at the reference point at the freezing point of water. So for the modern standard in science and engineer now, we use the temperature in Kelvin scale. So the best way is to transform all temperature you use to the Kelvin scale before perform any calculation. This chart represents some example of the temperature in Kelvin scale for various physical process. The highest here at the 10 to the 8 Kelvin. 10 to the 8 Kelvin. Here is the temperature of the hydrogen bomb, and it's higher than the temperature interior of the sun. And if you go further, this is the temperature of the surface of the sun. Please notice that the scale here is not linear, but it's a log scale because the range of the temperature is very wide. The freezing of water is about here, which is about 273 degrees Celsius. Liquid nitrogen is about 100 something. Liquid hydrogen is about 10 or less than 100 Kelvin. Liquid helium is about 1 Kelvin. The lowest temperature that the human head can achieve now is about to the 10 to the minus 9 Kelvin. It's very close to zero, absolute zero. But for the knowledge we have now, we know that we cannot reach the point of absolute zero. We can get closer and closer to absolute zero, but we cannot reach the absolute zero. That is the physical limit that the human can go in terms of the temperature.